but I did already go ahead and say that. Now, Catalyst IOS uses MLS, or multi-layer switching nomenclature, along with some modular quality of service command line. I love the acronyms of acronyms. I'm just waiting for when we have acronyms of acronyms of acronyms, which I venture can't be too far off. NXOS, everything uses the MQC nomenclature. The idea was to simplify everything, and it was also to unify the hardware and to abstract different levels of hardware capabilities from having different command lines as we were used to with the Catalyst QoS. So it's still a three-step model. Still a three-step model like we're used to in any MQC. So what we're going to do is we're going to create class maps, which go into policy maps, which are applied with service policies. Okay? Really no different than anything if you've ever done quality of service on even a router. Create the class map, it classifies or matches the traffic. That goes into a policy map where we, based on that class, affect the traffic in different ways. This might be effect, it might be affect at any rate. And then we apply that to the interface with a service policy. Now, the difference is in NXOS, we have three different types of class maps, policy maps, and actually four if you can count control plane policing. So for we've got one type, which is of type QoS. This is basically used for classification and some marking. It's really used for classification primarily. We've also got the queuing. This is what does the cost to queue mapping. This is what does the, what are we going to turn on weighted red? This is what really affects the hardware itself. Okay, this is, and I'm going to bring up the Catalyst 6500 comparison, but this is really what directly affects that hardware. Are we going to do policing? Are we going to do shaping? What is it we're going to turn on? We can turn on multiple, are we going to create a strict priority queue? We can turn on multiple things that are logically insane, that don't work based on the hardware. So we could tell, let's say, a queue to be a priority queue, but when we go apply it to the hardware, it says, can't turn on priority queuing because you're not talking about a priority queue. And I only, from a hardware standpoint, have one priority queue, for instance. Or you could tell it to try to turn on, well, we're going to take a look at some examples of some things that won't actually apply. The command line parser doesn't stop you from putting something that's logically insane into the command line, but when you actually go apply it to the hardware ASIC, when you actually go write it to the port, and that actually writes down from the supervisor to the hardware ASIC, it will perform a sanity check and say, does the hardware support this? If not, it's going to kick back an error, and it won't let you do it. Then we also, and again, this is analogous, the queuing type is analogous to Cat iOS, things like the MLS QoS SRRQ, or the MLS QoS QSet output buffers, where we're actually defining the amount of memory for, in this case, egress queue, or QSet, or template. Or MLS QoS QSet output threshold, where we're defining what traffic is going into what threshold. And then finally, we really have something brand new to Nexus, and this is called the network QoS. This is actually dealing with the quality of service inside the fabric, the central fabric of the system. So there is this new entity, and again, it's not necessarily new. It is in other platforms, but you may not be used to it, and that is the QoS group. This really allows an abstraction from simple, or for the purposes of simple mapping, I should say. So the idea is that I classify traffic, and then I give it this tag, which is very quick to look up, even faster to look up than the class of service, or COS value. And it also is just something that I can refer to system-wide. So this allows the abstraction for simple mapping. For instance, I could map one or more classes of traffic to a particular QoS group and then apply that QoS group to a particular queue. And as we'll see in the Nexus 5K, this is really how we do things. So when I'm configuring queuing, or even when I'm configuring control plane policing, just as a note, I have to do those in the default VDC, and they may momentarily disrupt traffic depending on what I'm doing with them. The reason for this is that I can't really affect hardware except in the default VDC. Okay, so that's the one thing that we can't do. I actually already had that, so I'm not sure why I have that twice. The type of QoS. I see. It got carried over to the next slide. So my different class map and policy map that is of the type QoS, I already mentioned this. This is primarily for classification. For the type queuing, this is where we do anything that affects the system-wide cards with the particular ASIC capabilities, such as strict priority queue, distributed weighted round robin, as opposed to shaped round robin. And we can always see what the individual capabilities of the card are, and we're going to do that in a moment, by doing show, and this is really not any different than Catalyst iOS, by saying show port number capabilities. Okay? Now notice that there is actually going to be a pause in the actual NXOS interface when I apply a cost value to a queue. This is really the switch writing that instruction live to that hardware switch on chip. I already mentioned this. There's a sanity check performed. I give an example. So for instance, if I say class type queuing and I say 8Q2T, and this is an 8 queue, but there's no priority queue, and I use the command priority level 1, the priority action is not allowed in an input direction, for instance. Okay? We're going to take a look at some of these predefined names. So they have names, and the names reflect the hardware capabilities. Okay? So it actually makes a lot of sense. The in versus the out here, that reflects the direction. Am I applying this in an ingress or an egress direction? Of the 8 queues and 2 tail drop thresholds, which queue am I working on? I'm working on Q1 of those 8 queues. What's the hardware capabilities? I shouldn't even begin trying to configure an 8Q2T ingress Q1 if I don't have hardware that supports 8Q2T. I need to do a show port capabilities or show Ethernet 1/1 or 2/1 or whatever port I have capabilities and see what is the receive queue capabilities, what are the transmit queue capabilities, and then I need to configure classes and policy maps for those types of hardware capabilities. Otherwise, it's just an exercise in futility. So, queuing attributes in the policy map. Some of the different things that I can do priority, and I can actually specify a level 1 or 2, although only level 1 is really available today. I assume that level 2, of course I don't know that. I don't have a M2 or an F2 card to see. Maybe level 2 is available in those newer generation cards. But I define the queue as a strict priority queue. Again, strict priority means if you get in my queue, you are getting on the wire before anyone else. You have VIP status. Bandwidth. Bandwidth really is something I think is misunderstood. Bandwidth does not necessarily mean you get X amount of bandwidth. You know, if this is a 10 gig interface and I give you a bandwidth value of 10, does that mean that you get 10 megabit, 10 gigabit, 10 what? It's really a ratio to the other weights, the idea of weighted round robin. So I'm going around in a circle. If I have 8 queues, I'm going around to Q1, Q2, Q3, Q4, Q5, 6, 7, 8, and I'm servicing them at different intervals. So if Q8 is, and forget about priority queue. If you're a priority queue, basically if there are packets there or if there are frames there, you get onto the wire first. Carte blanche. If on all the rest of my queues, or if I don't have a priority queue, if I have queues weighted, let's say Q8 is weighted with a value of 80, and you can do things in, it's all a ratio, so I can do it in values that equal up to 10, that equal up to 100. They don't have to equal anything. It's all going to be a ratio. it tends to be easier, I think, and my students tend to find, if I make all the values equal 100, because then I'm basically saying what percentage of the overall bandwidth are you getting, okay? But it's basically a ratio. If I say Q8 is a 10 and Q1 is a 1, then I'm servicing Q8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm circling around and getting Q1 once. Grab a frame, go over, see what Q2 is. It was a 3, 1, 2, 3. Go over Q5, it was a 2, 1, 2. Go over to Q8, it was a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Circle back around. The whole idea of a round robin and servicing. So that's really what the bandwidth is there. Okay, shape. This is also something that's commonly misunderstood, but this defines the shaped round robin. So I'm still going to go around to the different queues. I'm still going to service them in a round robin state, but I'm going to define an inverse absolute weight. So if I have a value of like 5 for a particular queue, this is 1/5. Okay, it's an inverse to the queue as a whole. Bandwidth tends to be a shared or a distributed weighted round robin. Shape is an inverse absolute. Okay, so this, if I have a 2, you get half the bandwidth. If I have 5, you get a 1/5 of the bandwidth. If I have 10, you get a 1/10 of the bandwidth. 20, you get 1/20th of the bandwidth. Make sense? But it also disables priority queuing. Okay? The queue limit command actually defines the queue size or depth. It also defines essentially tail drop thresholds if I continue out with the syntax and arguments. Again, what's the queue depth? How deep is a queue? What does that mean? What does it mean when I say a queue has depth to it? This is really the amount of memory, right? How deep, how many packets, how many frames, how many, whatever it is I'm trying to say, does, and if I'm speaking in terms of like, something other than bytes, how many of that is it going to take memory in order to store that? That's my depth. At the end of it is a threshold. I may not let everything come up to the full queue potential. 100% of the queue is 100% full. All my memory is being used. So some things will get into the 100% category, as I showed with that really badly drawn graphic illustration earlier. But for Q1, or I'm sorry, not Q1, but let's say tail drop threshold 1, maybe I give it 10%, and then you only have 10% of that queue depth before packets begin or frames begin dropping off the tail end, the tail drop. Random detect, I'm going to define my weighted random thresholds per queue. Tail drop and weighted red are mutually exclusive on a per queue basis, so they can't exist at the same time. It doesn't make sense. Weighted red, I'm intentionally dropping. Tail drop, you've just reached the buffer limit. Now the new type of network QoS. These are system class characteristics. Things like drop or no drop. Okay, we talked about what's our no drop queue or no drop network QoS class going to be. That's going to be for FCOE. I also set MTU here. Now this is something that is not something you would traditionally necessarily have set before. This is a little bit different in the sense that when we think of the command MTU, we typically think of the command IPMTU, right? With IPMTU, we're setting that on a layer 3 routed interface. And we're defining the MTU for the packet size. But what's the difference between layer 3 and layer 2? Fragmentation is available. So at a layer 3, I can fragment. And assuming that my application doesn't hate me for doing it, TCP, I can put a fragmentation sequence number in there and I can reassemble it the other side. You don't exactly fragment Ethernet, okay? It's not like it has reassembly numbers in there. So you need to size, when we're talking about network QoS, we're talking about layer 2 MTU. We're talking about the entire size needed for a given payload within that Ethernet frame. We're not taking into account the Ethernet frame itself, and actually different switch architectures may or may not. So you want to read the specifics of that particular hardware architecture documentation to see if it actually takes that 12-byte Ethernet frame into account. okay? But at any rate, actually 14 byte, because I have a 2 byte ether type. So at any rate, whether it takes that 14 byte into account or not, you need to read. But typically, what's going to be set is going to be what you're going to use. So 2112 for FCOE, probably 1500 is going to be fairly standard for Ethernet. For jumbo frames, I can set it up to like what, 90, I think it's 9216 is the limit for my iSCSI jumbo frames. It just depends on what you need to set it to. Your FCOE, you can't change it, okay? You can put traffic into a class where FCOE should be. And again, signaling may fall into this class, and that may not be a bad thing. It may not hurt us. We don't want to put anything else into that class. But there are some things that we cannot do. First of all, we can turn on or off by default, the FCOE class or network QoS group for FCOE in a 5500 series switch. It was on by default and you couldn't touch it in the 5010, 5020. The reason that Cisco finally let you in the 5500 was because enough customers called in or wrote in and talked to their SC and account manager and development team and said, listen, we don't do FCOE, and that's buffer memory that we can't store any frames in. You're basically taking it away from us. We paid for it, but we can't use it because it's locked there only for FCOE. So that's when Cisco said, you know what, that's a good point. Not all environments have FCOE. The switch was built with FCOE in mind, but not everyone has it. So we'll unlock that, we'll leave it off, and you can tune that. You can turn, not tune it, but you can tune it a little bit. We're going to talk about one thing for the in general. So okay, so taking a look at buffer size, we can allocate the different buffer size. We can change the marking. So 3 attach points for the policy types. Think of how the frame forwards across the switch. It comes in a port, it hits the crossbar fabric, it goes out the port. So on the ingress interface, we can do QoS type. We can also do ingress queuing. At the unified crossbar fabric, we can do QoS type. And we're going to talk about one of the reasons we might want to do this with the 5500, specifically with the layer 3 daughter card in a moment. We can do queuing across the fabric, and we can specifically, mainly queuing here is we're going to not actually be doing queuing per se, but we're going to be using the queuing MQC structure to turn on, like I said, change MTU, 2112 for FCOE, things of that nature. Network QoS type, this is where we can affect those MTU and other things. So queuing is where we would have done things like weighted red or strict priority or things like that. And then there's also the egress interface where we can do egress queuing. Now, there's sort of a 9-step configuration process that I've outlined. We define the type of QoS, or I should say we define for the type QoS in a class map, okay? Then we define the type QoS policy map and call those type QoS class maps into play and do things to them, classify, match, mark, etc. And then we apply that type QoS policy map. Then, as you might imagine, with the attach point, we define the type network QoS. So that last one was the ingress port. We do this at the ingress. We type QoS, type QoS policy map, and then apply that policy map. Then we create the type network class map, the network QoS policy map, and attach it globally. Then we define the type queuing class map, define the queuing policy map, and attach it. Now this is assuming an egress queuing, but again, we can do it on the ingress, and that's where we do it if we are configuring a Nexus 5500 or F series line card. Okay, hardware specifics. The Nexus 5000 had a 4 system default QoS QoS group classes defined. So there were 2 for cost 6 and 7, really still are 2 for QoS cost 6 and 7. There is class default or 0, and there is the FCOE class. So out of 8, that leaves us 4 that we can use. Okay, kind of limited. 5500 changes this. No FCOE is defined by default, so we can use that if we're not using FCOE. If you're using FCOE, you must allocate this properly. No two ways about it. You don't have to, but you're going to drop FCOE traffic. Okay, so the Nexus 5500 Layer 3 daughter card. This is kind of a special situation where as the traffic passes up through the Layer 3 daughter card, the cost value is actually lost. And so we basically have to reclassify and remark this traffic. Otherwise, things like voice, video, and signaling end up in the default queue. Okay? So this is bad. We would never have FCOE end up in the default queue because we don't route FCOE. There is no Layer 3. Okay? But any traffic that we route, if we're routing it in the 5500, we have to reclassify it. The easy takeaway is that if you always set the cost value, even when you're just calling a class map from a policy map where you had just previously classified based on costs, then your bases are covered. You don't have to worry about it because it's always done for you. Okay? The other takeaway is don't use the 5500 as a Layer 3 switch. It was intended as a Layer 2 switch, but obviously cost is going to dictate there. More hardware specifics. For the Nexus 5K and 7K treatment, FCOE is cost 3, but Nexus 5K matches both, and actually 7K does as well, on cost 3 and the ether type 8914 and 8906 for FIP and FCOE respectively. I wrote those out. There it is. There is a hardware override to ensure that they make it to cost group 1 and ultimately to the proper no drop queue. Okay, you can't get FCOE out of cost group 1. You can misconfigure, and I've already said this, and put other things like signaling. Signaling would be one of the ones that wouldn't necessarily be a misconfiguration, but it might, it just depends on your particular set of business requirements. If you want to remark signaling to 4 or 2, use it somewhere else and then remark it later, that's fine, but certainly don't put anything else other than signaling in there. You can tune FCOE, but only for distance. So this is physical distance of the fiber. So 300 meters is the actual default tuned distance. This is an MTU of 2158. Pause no drop is on, and here's an example of tuning it for 3 kilometers. Okay, MTU still 2158, but the pause no drop at the end of that command has the argument, the buffer size, 152,000. And again, this is the buffer size. This is basically saying, hey, we have longer distance to traverse, so based on that, we're going to pause or send a pause if we go above the threshold of 103,360, and we're going to resume when we fall back below 83,000 bytes. But the overall buffer size, the maximum, is 152 or 152K. Okay, hardware specifics for the Nexus 2000. This is a Layer 2 line card. This is not a switch. The FEX is not a switch. And it's also not a distributed line card. So what we don't have is instructions written from the supervisor or the 5K, whatever we're working on, down to the line card where it can switch traffic locally. It also is only able to classify on cost value. Now, we talked about the others are only able to map to queue on cost value, but they can still classify DSCP. We can classify traffic to DSCP from a FEX, but it has to first come up from the FEX into what are called the UPC, or the Unified Port Controller. These are basically the port controller that handles the hardware architecture for the FEX ports as they are leaving or coming from basically the 5K attach ports, okay, where we said switch port mode FEX fabric. those are the unified port control, or I should say the unified port controller controls any ports that we turn into switch port mode FEX fabric. So once they come up through the UPC, then we can classify based on layer 3. Nexus 7000, FCOE is only supported on F-Series line cards. There's an existing non-changeable policy template for FCOE. And now we're going to actually take a look at, I've already said all this, but we're going to take a look at some breakout configs. Let's log into a switch, and let's go ahead and we'll just do a show interface E11 capabilities. And we'll note that our QoS scheduling for receive queue, we've got an 8Q 2T model. Now again, this is an M1 line card, so the majority of our queue buffer memory is allocated to the transmit or egress direction, where we have a 1P, 1 priority, 7 non-priority queues, and 4 overall tail drop thresholds. We can do class of service and type of service rewrites. And this gives us a lot of other information, but that's pretty much the important bits for us for quality of service. If I do that same command, but for the E2/1, the F1 32XP, I see that I have an 8Q4T. Previously on the ingress, I had an 8Q2T. So this is where the majority of our ingress memory is here, is on the as I just said, on the ingress. But the 8Q4T, and then on the egress, the transmit direction, I actually have 3 priority queues and 5 non-priority queues for a total of 8 and 1 overall tail drop threshold. Okay, so the QoS capabilities are quite different. So let me just go ahead and bring over, let's see, oops. Let me bring up a text document here. And I think what I'm going to do is I'm just going to go over some of the stuff that I've written out. And again, all of this is in the configuration guides on Cisco.com. But here's what we might want to do. Classify on ingress, and this is for a 5500 series switch. Okay, so I've created different class maps here. Class map type QoS. And by default, if you don't type anything, if you just say class map match any or match all, again, match all, matching all the criteria in there, Boolean and, match any, Boolean or. But if you don't type any type, or if you don't, configure any type, it's going to be the type QoS. So I've just labeled it QoS cost 1, and I'm just matching based on cost 1. Okay, I've got match all cost 2, matches cost 2, and so on and so forth. Fairly self-explanatory. Then I have maybe gone ahead and created some access lists. So I created access list QoS voice, permit, UDP from anywhere and from the range of 16.384 up to 32.768. Really, this should be 32.767. Well, I guess actually, if it's a range, it would be 32.768. If it's a increment by, it would be 16.387. Anyway, to the range of 16.384, 32.768, and then deny any IP. So all I'm doing is using this for classifying my interesting traffic. Maybe I created an access list for QoS real-time video, and I specify a particular subnet where I want that traffic to come from and go to, a place where I know where I have video-based traffic. And it's on the ephemeral ports above 1023. And I have IP access list QoS signaling where I enumerate out TCP 2000 and 2443 for skinny and secure skinny, 5060 for SIP. I didn't put 5061 for secure SIP. I could have done that. UDP 24, 27, and 28 UDP and TCP, I should say, respectively, for MGCP and backhaul, Q931 backhaul, and 17, 19, and 20 for H323 RAS and H323 fast start. Then I just create class map type QoS, and I can match those access groups. So I'm basically doing the same thing as I was up here, but instead of matching costs, I'm matching based on explicit classification. Then I create a policy map, of type QoS, give it a name, and I say call QoS class voice. Set the QoS group to 5. Call class real-time video. Set the group to 4. Signaling. Set the group to 3. Then I call some of the other classes where I matched based on the existing cost value. Trust those, essentially. Set the QoS group to 5, 4, 3, 2, and then also for 1, I'm going to set the QoS group to 2. The reason being QoS group 1 is hard-coded for FCOE. Want to leave that for FCOE. Okay, then I'm going to apply those to a system QoS, and applying to the system QoS really applies to all ports and ASICs at once. So it's quite effective, and it minimizes my configuration bloat that might occur. So I can say system QoS service policy for the type QoS, because I can put other service policies here for the type like network QoS or queuing, and I specify the direction. So input QoS classify. So what I'm basically saying is go write out, effectively write out to every single port on the ingress direction this QoS service policy. Okay, it's the same as going to every interface and saying service policy type QoS input this policy for classification. Okay? And then I might also choose to override the system QoS per port as needed for one-offs. So if I put something on the port, it's more specific than what's in the system. Again, on the 5000 and F cards, I'm going to queue on the ingress. So I'm going to match the QoS group that I previously set in the QoS type service policy. And for the type queuing, I'm going to match that group. Then I'm going to create a policy map with that type queuing. And then I'm going to call up the class that I just used, and I'm going to set, let's say, bandwidth, for instance. So bandwidth %25, bandwidth %15. Maybe I'll set priority along with bandwidth %15. So again, this is saying strict priority. In iOS, this would have said priority 15%. So something like that, or priority %15. Okay, it's just doing those two things, but on in iOS, it was still doing two things. It was just on one line. In NXOS, it's doing the two things on two separate lines. And then I'd go back to maybe system QoS and say service policy type queuing. Input. Why input? Because I'm on a ingress, primarily ingress queuing architecture. Then I need to deal with the system crossbar fabric QoS. So I'd say something like class map type network QoS. Okay, so the type network QoS is the difference here. And I just labeled it NQ for network QoS, cost 5. So I'm matching those QoS groups that I previously set, that temporal tag that I applied. And here's where the magic comes in. Here's where the bulk of my configuration comes in. First of all, I have two class type network QoS that I can't change per se. Well, I can't do away with them. And that is something we're probably already familiar with, class default. And then I also have the class of class-FCOE. The MTU is 2158. Pause no drop, which is auto-tuned, not like the auto-tune in YouTube. And I'm not going to do a demonstration. I thought about it, but not a good idea. But auto-tune for 300 meters. Probably don't need to change this. Pause no drop for the buffer size that we talked about earlier. Custom tune for 3 kilometers. If you need something different than that, see your system SE from Cisco, and they will get you in touch with the developers to come up with a custom number. But don't change that yourself at all, unless you really know what you're doing. Okay, then I pull up my network QoS for NQ cost 5. Maybe I set the cost to 5. Again, remembering that this could be as the traffic is coming into the crossbar for the first time, but it's also as it's leaving, I'm sorry, not the crossbar fabric, but the layer 3 daughter card of a 5K coming into it. So we don't necessarily need to set the cost. We do need to set the MTU at that point, but if it's coming back out of a layer 3 daughter card, we need to tag that cost value again. Okay, the MTU, now it didn't lose its QoS group tag. It just lost its cost tag, its layer 2 cost value. So we set that cost value again. We set the MTU, which we actually don't have to do that. The default is 1500. And we optionally set the queue limit. How deep is the queue? Okay, here's cost 1. Maybe we're tuning this particular network QoS for 9216, something like iSCSI. And then we apply that service policy. Now, I also promised that I would give you a bit of, actually one other thing I want to mention that you can do with the layer 2 FEX. Other than classifying things on the ingress port, other than doing standard 5500 or 5K information in terms of ingress queuing, in terms of ingress classification based on cost, or ingress classification based on DSCP if I'm coming into the UPC ports. One of the other things I can do is I can tune the overall hardware limit. This is actually done under the FEX command. So FEX 102 or 101 or whatever you've specified, I can say based on the hardware, if it is this type hardware, for instance, this is what we have, one of them, set the queue limit for each queue to this depth. Now the problem is I can potentially create queue depths that are larger than what the overall switch has or line card has available to it, and I can starve other queues. So you really want to be careful when you're tuning this, but it is something that we have available to us. And the last thing I want to show is a comparison, and I'm only using the same document because I've got the font face in large enough to where I want it for the screen, but I'll post these in 3 separate downloadable class file documents. So an example, I actually have 2 different examples from 6500 config to Nexus 7K config comparisons. So 6500, we turn on MLS QoS. We do something like an interface range, and we do an MLS QoS trust DSCP, or an MLS QoS trust cost, or MLS QoS trust device Cisco phone, where we make it a conditional trust of the DSCP or of the cost if CDP or LLDP med tells us that it is a phone. Then we have something like weighted round queue bandwidth, 100, 150, 200. Again, we're not giving it 200% of the bandwidth. We're simply saying service this Q3. Now, this was defining the distributed weighted round robin scheduling for a 1P3Q 8T. So what is it we're defining the bandwidth for, or the servicing for? We're defining the servicing for the 3 non-priority queues, these guys right here. The priority queue doesn't get servicing. It's strict priority. It always gets its bits on the wire first. But Q3 is going to get its bits service, or its queue service twice as often as Q1, and it's going to get basically a 2 to 1.5 ratio to Q2. I could have just as easily done this, right? 10, 15, 20%. Okay, next if I take a look at 1P 7Q8T, I should have 7 values here. 1, 2, 3, 1, 2, 3, 4. So I'm essentially saying Q1, 2, and 3 are defined. The others are not defined. They don't really get a share. They're not considered. I probably am not putting anything in those queues. If I am, then they are, if I am putting something in there, then they're just getting serviced best effort. So then I actually have my weighted round robin queue cost map, where I actually have Q1 and threshold 1 I'm putting cost value 1. For weighted round robin Q, cost map Q1 threshold 2, I'm putting cost value 0. Q2 threshold 8, because remember this is a 7Q 8T, or really 8 Qs if I count the priority queue. At threshold 8, I'm putting cost 4. Q2 threshold 2. And one of the things, this always seemed to confuse a lot of people, it's really simple if you do a question mark. This is one place where I highly advocate a question mark. If I get out here to weighted round robin, cost map, and I simply say question mark, it's going to tell me what value is it expecting next. Is it a Q? Is it a threshold? Or is it a cost value? Or is it a DSCP value? Yeah, actually, it would be DSCP if I did a weighted round robin Q DSCP map. Okay? But I did cost map to compare because Nexus can only do cost mappings to the queue. So then I also have priority queue, cost map, Q1 is my priority queue, and I'm going to put 5 in there. Okay, the Nexus equivalent, I have my 1P7Q4T in the egress direction, and specifically I'm dealing with the priority queue, matching cost 5. So I'm putting cost 5 into the priority queue on the type of hardware that has this particular egress or transmit queuing. And by the way, this is not an arbitrary name I came up with. This is in the system. So if I just did class map type queuing match any question mark, in fact, let's just do that here. Class map type queuing, match any question. I've got all of these predefined. This is basically all of the types of hardware that it has available to it. Whoops. So, and it's really helpfully telling us, hey, this is specifically the egress queue out, the egress queue 3 of any type of hardware system-wide that has the hardware type of 1 priority queue, 7Q, and 4T. So what do? I do that show E21 or show E11, whatever card I'm wanting to configure, and I say, hey, this has a 3P5Q1T. Okay, so I come back up here and I look for 3P5Q1T. And I don't see 3P5Q1T. Okay, that's interesting. So let's do, but do I see an 8Q4T? I did, I only see an 8Q2T. Did I? Let's do a show interface E11 capabilities. So I do have a 1P7Q4T. So here are all my 1P7Q4T in the egress direction queue types. I'll have to take a look and see why I didn't see the one for the F-series card in there. But I've got my default queue, I've got my Q1, which is my priority queue, and I've got queues 2, 3, 4, 5, 6, and 7. So what does that mean? Default queue is Q8. It's the only thing it can mean. So I go into that, and I actually say, what type of traffic do I want to put in which queue? This is the equivalent of this bit here, weighted round robin, cost map, queue, and then ignore the threshold, because I'm not doing queue and threshold on the same line like I do in CAT 6500, and I'm saying the actual cost value going into the queue number. Then I'm saying policy map type queuing, give it a name, call up the class type queuing that I just defined, or really that I just called into play, say is it priority, what is the queue limit, queue limit maybe I can actually say not just hard limit depth, but I can actually say percentage. I can say bandwidth remaining percent to define those bandwidths. So this is more for a 7K. It is a little bit different than the 5K, but it still uses the same MQC architecture, with there being a lot more granularity and really a lot of different hardware line card types. That's where I have to have a little bit of different command line structure. It's still in the MQC, but I have to define per line card type, whereas the 5500, depending on which 5500 you have, it's all the same thing for that box. Okay? And then I'm going to apply that in the egress direction. on my queuing. So this was for a 1P7Q4T out. Here's another example of new example of a Cat6K with weighted red and 8 queues. So let's say I've got interface range 10 gig Ethernet 1/1 through 4, and I want to say that I'm creating queue limit. I'm basically allocating buffer space to my non-priority queues. Okay, so this is 1, 2, 3, 4, 5, 6, 7. So my 7 queues up here. I'm basically saying that I'm allocating 5%, 25%, 10%, 10%, 10%. So these are 30, 45, 55, 60, and 70. So I'm actually only allocating 70%, really leaving 30% left over for that priority queue. I also can do the bandwidth or the distributed weighted round weights. Again, ratios to the overall. And then I can say weighted round robin queue random detect 1, 2, 3, 4, 5, 6, and 7. So I am going to set my minimum and maximum thresholds for the non-priority queues. Okay, so the minimum threshold for, and this is actually, if I go back up, this is 8 tail drop thresholds per queue, per non-priority queue. So for Q1, I've got 1, 2, 3, 4, 5, 6, 7. Was that 8? Let's see, 4. Yeah, because I'm going to have my my priority queue is going to be at 100%. So basically, I'm saying that all of these, except for the first tail drop threshold, are at the full 100% of the queue value. Okay, and this is kind of typical, but I could certainly say that I want, different tail drop thresholds. Okay, and then I assign that traffic. We actually already saw that before. Okay, so I'm assigning things like spanning tree, Q7T1, let's say video, Q3T1. So Q3 tail drop threshold 1 is cost value 4. So the example here, we already showed the cost to queue mapping. And now we're going to basically take a look at the tail drop to threshold mapping. So I've got optional. If I take a look at the queue limit command, I'm saying cost value 1 and cost value 0. Those are both falling within this hardware type for egress, but specifically in Q2 at threshold 100% or threshold only 50% of however much memory was there and however often it was serviced, but specifically of the queue limit, however much memory was assigned to this Q2. Cost 0 can use up to 100%. Cost 1, which is my scavenger traffic, can only use 50%. Now I've got these commented out because these are drop threshold values. And I can either use drop thresholds or I can turn on random detect cost based. So this is weighted random early detection based on the cost value. I can turn on weighted red, otherwise I have drop thresholds. I cannot turn on both. These are mutually exclusive from one another. Here I also have random detect cost 7, and I give it a minimum threshold and a maximum threshold. Okay, and I'm just going ahead and doing these pretty much the same thing for the different queues, Q3. And if you actually put this Nexus information beside the Catalyst 6500 information, it begins to make a little more sense side by side. Okay, but I'm doing the same thing. So for instance, let's see, what did I have? Let's do our video. Cost 4 was in Q3 threshold 1. Where's my cost 4? There's cost 6. There's my cost 4. First of all, I'm saying it's random detect or weighted random early detection based on cost value. Cost based is what makes it weighted red. If I just said random detect, it would just be red. I'm saying cost 4, a minimum threshold of 80%, a maximum threshold of 100. So that's where I'm really doing the cost to threshold mapping. And again, I can do DSCP. I could say random detect DSCP based and random detect DSCP CS4 or AF41, and then define the threshold mapping from there as well. Once I've defined all those, then I can tie it to the queuing output on the individual interface, or system-wide if I like. There is actually default QoS. In fact, let's just take a look at this here real quick. There is some default QoS in the system. Some of the things that you'll see are all of the no drop and drop classes. So specifically some of the things for FCOE. And again, we'll get into more with FCOE as we get into the storage class. We'll probably use a lot of the system defaults for those FCOE classes, and we probably won't need to define anything else because it will make sure that the FCOE gets into the proper class, doesn't get dropped. We want to make sure that drop classes have no pause, that they have some sort of congestion control like tail drop or, and we can only again have one, or random detect. We want to make sure that our FCOE end drop or no drop, basically no drop has the pause frame turned on or the pause capability. We have no congestion control, random detect. We always have tail drop at the end. We can't physically store more frames than we have buffer or memory space to do so. It's just not possible. Makes sense, kind of. MTU 2112, again, hard-coded there. So we've got a lot of different defaults. Actually, one of the things I want to take a look at real quick, we've also got some default table maps, so CIR markdown or peak information rate markdown maps, okay? So the default is to copy, but if I want to say from DSCP value 10 or 12 to DSCP 14, basically these are things that we can call into play to do mutations. So either based on, let's say, a color policer, or just if I want to actually do DSCP or cost-based mutations, I can do those. Okay, one of the other things I want to take a look at very briefly, and again, I'm by no means going to go into every line, is the control plane policing. I basically want to show you that they have thought of a lot. So first of all, we start out, they've pretty much thought of everything in NXOS to protect the control plane. They start out with all the IP access lists that they've defined. So something like permit TCP from anywhere greater than 1024 to anywhere equaling BGP, and the converse. Okay, and obviously that's the system ACLP, ACL for BGP, BGP version 6, which really isn't any different that I can see at a quick glance. CTS, so Cisco TrustSec, TCP, port 6449 and back from 6449, DHCP, equaling boot PC and not equaling boot PS, but equaling back from boot PS. Okay. Control plane for ACL, DHCP relay response, EIGRP, EIGRP for V6, FTP, strangely enough, even I guess maybe just to FTP traffic to and from, files to and from the supervisor, global load balancing, HSRP, so our different FHRPs, ICMP. Again, I'm not going to go over everything, but there is a lot here, including a lot of MAC-based ACLs that they have defined, very specific MAC addresses that are used by the system. MPLS labels, MPLS OAM, RSVP, all sorts of stuff. I'm not going to go over it all. You can see it, you can read through it. Show run all, if you want to see it. Show running config all. Then they go into the control plane and state the scale factors And they create a class map for type control plane, which is that fourth type, and they call all the access groups, and they call them in a few different specific classes. Once they're done calling the classes and calling the access group from those classes, they create the policy map, and they actually begin setting the cost value. So things like critical traffic, they set at 7 and give it a policer so it doesn't overwhelm. Okay, so a CIR, B sub C value for burst, and then conform should transmit, violate should drop. So really a 1 rate, 2 color policer. Okay, and so on and so forth on down. And then they apply that control plane policy to the control plane using a service policy input and calling the policy map, and then saying control plane policing profile strict. So that's the control plane policing. That's a default part of Nexus 7K. Again, they've really thought of everything. I haven't gone through it and found anything that I thought they missed, and certainly a lot more that I knew in terms of MAC addresses and everything. So it's really quite exhaustive, and it's quite useful.